Good day to all. Today we are going to see about the three-phase induction motor. Just we'll see the outlines what we are going to see in the three-phase induction motor. First introduction, then what are the types of electrical machines, then types of three-phase induction motor and basic principle and working principle and so on. We'll see one by one. See, the electrical machines are electromechanical energy conversion devices which this electrical motors converts electrical energy into mechanical energy, and electrical generators are vice versa. Most of the industrial load are inductive, especially three-phase induction motors are widely used in the industrial applications for continuous operations. See the types of electrical machines. What are the types of electrical machines? First one is AC machines, then second one is DC machines. In AC machines, the single phase induction motor will come and the three phase induction motor will come, synchronous motor as well as single phase transformer and three phase transformer, alternator or AC generators. These are all the AC machines. Then DC machines. In the DC machine, there are mainly two types. First one is DC motors and DC generators. In DC motors, we'll have a division of that DC shunt motor, DC series motor, and DC compound wound motor. Then the DC generators, DC shunt generator, and DC series generator, and DC compound wound generator. These are the types of DC machines. See the principle and operations of the motor is the rotating magnetic field RMF is set up in the stator when three-phase power supply is given. If you are giving the three-phase power to that stator, then the rotating magnetic field RMF is produced in that particular induction motor. Then the stationary rotor cut the revolving field, and due to the electromagnetic induction, a EMF is induced in the rotor conductor. As the rotor conductor is short circuited, current flows through it becomes carrying a conductor in magnetic field and start rotating. See, this rotor conductor is short circuited, currents flow through them, then it becomes a current carrying conductor in magnetic field and start rotating. Then the slip of induction motor. So induction motor always rotate speed less than the synchronous speed. So the difference between the flux ns and the rotor speed n is called slip. The percentage of slip, the slip we can say as ns minus n divided by ns into 100, where ns is a synchronous speed and n equal to axial speed of a rotor. So the formula for that slip speed is ns divided by n divided by ns into 100. This is the image of the three-phase induction motor. You will see the three-phase induction motor is look like this. Then these are all the terminals of the three-phase induction motor. The connections I have made. This is the outer diagram of three-phase induction motor. This is the cut view of that induction motor. If you are seeing that inside in that three-phase induction motor, it look like this same. See, this is the stator side and this is the rotor side. You will see in the stator side the coil are connected, and this rotor side also coil connected with that some insulation over here. This is the fan and this one is a cooling air flow. Cooling air must flow into that particular motor, because if any motor is runs, the heat might be produced. So for that, cooling air flow inside to that motor. And this end is a drive end. This end we can call as a non-drive end. Then what are all the components are inside in that three-phase induction motor? We'll see. First one is the frame, then stator, then stator winding, and rotor, and rotor winding, cooling vane, and bearings. We will see about all the things. See, first one is frame. What is that frame? Frame provides a mechanical support to the stator and the rotor, and it is basically made up of a casting material. And stator. Stator is a stationary part of this induction motor. It is a stationary one, and it consists of a stator winding. It is housed on the motor frame. Arrangement of this stator in three-phase induction motors are given below. You will see. See, this is the arrangements of that stator in that given. Then we will go to see the rotor. And this rotor is a rotating part of the induction motor, where stator is a stationary part and the rotor is a rotating part. Then it is housed on the shaft of that induction motor. This rotor has two ends. One is called driving end and another one is called non-driving end. The mechanical load is connected to one driving end, while cooling fan is connected on a non-driving end. See, mechanical load, which means the output is connected to that driving end. That's why we can call that's a driving. And other side we can connect with that cooling fan. That end will be called as non-driving end. Then this both the ends are connected with the bearings for free rotation, means of reduce the friction losses. This arrangements we will see here. This is the rotor arrangement and stator arrangement over here. Then these are all the components arrangements in that inside of the three-piece induction motor. See, here there are two ends of bearings are there, here and here, and this is the mounting plate. This one is case. Here it is rotor, and this is the stator, and this is the stator winding. This is the shaft and the short rings. Here it is the rotor, and this is the casing cap. The inside of this components will be like same. See, this is the assembly of that three-phase induction motor. We will see each parts of the induction motor. This is the fan cover. As we said, this fan cover is in a non-driving end, so it is a fan cover. This is the fan, and this bearings here also there, here also there. These two bearings are used to rotate the machine very easily. Then this is the eye bolt. Here the name plate is there. With the name plate we will know that how much current will takes place, how much power for this particular motor. And this is the terminal box. Here you can see this is the stator winding, and this is the stator, and here it is the rotor, and this is the shaft. This is a end seals, and this is a drain flux, and this is the V-ring slider. See, we are connecting to the driving end over here. That is a mechanical movement we will connect over here, and this side is a non-driving end, so we will just connect this fan. These are all about the three-phase induction motor. Thank you.